A first-class function is a function that we can treat and consider it to be a first-class citizen. A first-class citizen, in simple words, is an object. Well, in some programming languages, when we define a function, we actually get an object that represents the function, an object that has a reference, which allows us to pass it over to another function. Or, for example, we can define a function that when we invoke it, the returned value is a reference for an object that represents a function. So in simple words, when a function is a first-class citizen, or let's put it in simple words, when a function is represented using an object, it is very simple to pass over a function to another function, because we actually pass over the reference for the object that represents the function. It is also very simple to define a function that the returned value is a function, or to be more accurate, a reference for an object that represents a function. And that makes things very simple when it comes to functional programming, and especially when it comes to using higher order function. Now, in Kotlin, when you define a function using the fun keyword, you don't get an object. You get a function, just as in Java, a function. And if you want to pass over that function to another part of your program, or if you want to assign that function to a variable, it isn't simple. It isn't straightforward, because the function you created is not an object. Well, in other programming languages, let's take, for example, JavaScript. If you define a function, you actually get an object. And I can show that. Let's say we define a function, its name is calculate, it takes two values and returns the sum of those two values. Now, having a function that its name is calculate in JavaScript means that indirectly we have a variable, its name is calculate, and its value is a reference for an object that represents that function we defined. So it is possible, for example, assigning the reference for the object that was created when we define this function to another variable. Just specify the name of the function like that, the name of the function you defined, and you actually get the value of that variable that was indirectly created. The value is actually a reference for an object, and an object that represents the functionality, and a reference we can assign to another variable and then use it to invoke the function we created. Here, for instance, I print out to the screen the value we get when calling the function we created over here, a function that the object that represents it as a reference that is currently stored in A as well as in calculate. So you can either write A or calculate and then pass over the values, and actually by doing so invoking the function that was created. Just as you can see, it is also very simple to define a function that takes another function as an argument. Let's say we have a function, its name is calc, and let's say that it takes two numbers and a function. In JavaScript, creating such a function is very simple, because every function you define is automatically an object. Whenever you define a function and the code is executed, then an object is created, an object that represents the function you defined. So I can say that I want calc simply print to the screen the value returned when invoking the function we pass over, passing over the two numbers we also pass over. So now if I write calc and pass over 3, 4, and then specify either the name of the function, because as we said, when you define a function, you indirectly create a variable that its name is the name of the function, a variable that its value is the reference for the object that was created to represent the function. Now you can see that, oh, there is a typo. I wrote M. Let's change it into N. Okay, now let's execute it. The bottom line, you can say that calc, when we invoke calc, we pass over two numbers and a function we want calc to use. Doing so is very simple in JavaScript as well as in many other programming languages where a function is an object. For instance, PHP, Python, Scala. Well, in many other programming languages such as C, C++, Java, Kotlin, the function you define is not an object. And the only way for passing over a functionality to another part of our program would be defining a class where we also include a definition of a function, the function we want to pass over, and then instantiating that class and passing over the reference for the object that was created. And by doing so, we indirectly pass over a functionality to another part of our program. Well, it is a bit complex, but it is possible. And during the years till Java 1.8 was released, we were used to using the anonymous inner class syntax just for passing over a functionality to another part of our program. I can show that as well. Let's get back to IntelliJ. Let's create a simple class in Java. Let's call it program. And let's say that we have the famous main method. And then let's say that we want to pass over functionality to another function. It can be another function in the same class or in another class. Well, in Java, we were used to using the anonymous inner class syntax for doing that. It could be something like that. Let's say we have another method. Its name is calc, and we want to pass over functionality to this method. So for keeping things simple, we were used first to define an interface with a method, the method that will be implemented in the anonymous inner class that implements that interface. So let's define that interface. Let's call it calculation, whatever. And let's say that it includes a definition for one abstract method. Its name is, let's say, int f. An abstract method that takes two numbers and does some sort of calculation and returns the result. And when just defining this interface, things become simpler. We specify that calc, the method calc, as a parameter of the type calculation. And over here, calling calc passing over functionality would be done using the anonymous inner class syntax, as I mentioned before. It can look like new calculation, and then over here, let's say we want to pass over the simple functionality of taking two numbers and calculating their sum. So we should put here return num1 plus num2, and then over here, let's say that calc is a simple function that takes a functionality and execute that functionality, passing over two simple numbers 2 and 3 and print the result to the screen. So we should place here system.out.println a calculation and calling f, passing over the values 3 and 4. And now when we execute, well, just as expected, as of Java 8, we can write a simpler syntax instead. As of Java 8, we can write num1, num2, arrow, num1 plus num2. And by doing so, we can imagine that the compiler takes this Lambda expression in Java, and instead of that Lambda expression, plays code, which means which its value is a reference for a new object instantiated from an anonymous inner class that implements a specific interface, and the implementation of the abstract method coming from the interface is in according to the Lambda expression we write. So this is in Java. The same problem we have in Java, we also have in Kotlin. When you define a simple function in Kotlin using the func keyword, you don't get an object. So it is a bit more complex to pass over functionality to another part of our program. And in this course, we're going to learn about those ways Kotlin provides us to create objects that represent functions, and then passing over the references for those objects to other parts of our program. This is the topic this course focuses on. So we can still use the keyword fun for defining a new function in Kotlin, but we should also have a way for creating objects that represents functions, and then having objects that represent function, it would be possible to pass over the references for those objects, or in other words, it would be simple to pass over functionalities to other parts of our program.